Fine, we know the problem now. Determine how many zeros end with the 100 factorial. So the calculators are not going to help us, and writing programming on the computer will also not show you or display that biggest number, that large number, which represents 100 factorial. So when the problem's complexity is very high, the degree of complexity, it's better not to attempt to solve it at that degree of complexity, but instead we have to see whether we can reduce the complexity a little bit and then think whether it can be solvable or not. If not, you reduce little more. So for example, they have asked us to find the number of zeros that ends with 100 factorial. So approaching or attempting 100 factorial is very difficult, as we have discussed little earlier. So let us decrease the complexity. So let us think about 90 factorial and think whether it can be solvable or not, or comfortable for us to solve that problem or not. No, we cannot. 80 factorial, 70, 60, 50, 40, 20, even 20 also, it's not very comfortable for us to attempt to solve. Now we wanted to look at 10 factorial, because we already calculated the number that represents 10 factorial, that is 6,28,800. So what we think is that since the 10 factorial is little understandable and little comfortable, let us work on this to develop a base logic from the fundamentals to address the whole set of problem from 10 factorial to 100 factorial. So we can also divide this problem into 10 parts, 0 to 10, 11 to 20, 21 to 30, and so on up to 81 to 90 and 91 to 100. And let us find the solutions for each of those parts separately, and finally we can club all those solutions to get the final solution for the initial problem, which is number of zeros end with 100 factorial. Fine. Now let us look at the range, the first range, 1 to 10. So 10 factorial, 10 into 9 into 8 into up to so on into 3 into 2 into 1. Like 5 factorial, we cannot calculate what is 10 factorial just by fingers or by mouth, but instead even you need some little help from a calculator. So for your information, 10 factorial equal to, just now I told you, 36,28,800. Now if the question is asking us to find the number of zeros end with 10 factorial, we can easily say that there are 2 zeros. So 2 zeros will be ending with the 10 factorial number. Now let us look at some fundamentals, the basic logic to be developed. Why 10 factorial has got only 2 zeros? So 1 into 2 into 3 into up to so on into 9 into 10. So we know that the number 10, when it is multiplied with any number, that produces 1 0. And the second fundamental concept is that the number 5, when it is multiplied only by an even number, that will also produce 1 0. So 10 need not be multiplied with only an even number, with any number it produces 1 0. So the range 1 to 10, 10 is there at the end, that produces 1 0, and there is a 5 in the middle. When it is multiplied either by 2, 4, 6 or 8, that will also produce 1 0. Therefore the range between 1 and 10 has got 2 zeros. Now let us look at 11 to 20. So there is a 20 at the end, which is 10 into 2, so therefore that 10 produces 1 0, and we have a number in the middle which is 15, where the factors for 15 is 5 into 3, so that 5 will also produce 1 0. So the range between 11 to 20 will produce 2 zeros. Now if you look at 21 to 30, you may think that will also produce 2 zeros, which is not the case. It is a little different, because 21 to 30, there is a 30 at the end, so 10 into 3, so that 10 will produce 1 0. Now we have a number which is 25 in the middle, which is 5 square, which is equal to 5 into 5. So there are 2 5s in the middle, therefore those 2 5s will produce 2 more zeros. So totally the range between 21 and 30 will produce 3 zeros. Now if you look at the next range, 41 to 50, 31 to 40, that also produces 2 zeros like in the first and second cases. But 41 to 50 is again little different case. 50 is 10 into 5, So that 10 and 5 will produce us 2 zeros, and we have a number at the middle which is 45. The factors for 45 9 into 5, so this 5 will also produce one more 0. So the range between 41 and 50 will produce 3 zeros. Similarly, if you extend our logic, 51 to 60 will produce 2 zeros, 61 to 70 will produce two zeros, but 71 to 80 will produce 3 zeros as in the case 3, and 81 to 90 will also produce 2 zeros, but 91 to 100 will produce 3 zeros as in the case of third one. Because 100, 10 into 10, so these two tens will produce 1 0, and we have a number in the middle which is 95, so that there is a factor of 5 in 95, therefore that 5 will also produce 1 0. So totally the range between 91 to 100 will produce 3 zeros. Now if you summarize the whole effort what we have made right from the beginning, the first range to up to the last range, so we will get 6 ranges of numbers that produce 2 zeros for each range, and there are 4 ranges which produce 3 zeros for each of those ranges. Therefore 6 into 2 12, and 4 into 3 another 12, so totally 100 factorial number would be having 24 zeros at the end of the number. So I repeat, the 100 factorial number, it is very large, very huge, very massive number. So we don't know what exact it is, but how many zeros end with it has been just now discovered. So 6 into 2, 6 ranges, 2 zeros. So 6 into 2, 12 zeros. And 4 ranges will produce 3. So 4 into 3, another 12. Therefore 100 factorial number would be ending with 24 zeros.